Good day everyone. For my report, I will be discussing the methodological approach in the study of hydrology. This approach is essential for understanding how water moves through the environment and how we can model it for various purposes like conservation, prediction, and management. Now let's begin by looking the basic geographical unit used in hydrology, the river basin. The reference geographical unit, the river basin. This image shows the river basin, which is the main reference unit in hydrology. You may also hear it referred to as a watershed or catchment. Hydrological analysis within a river basin includes two major aspects. This is process understanding through observation and measurement, and mathematical modeling, which allows us to simulate and predict how water behaves in the system. As you can see from the diagram, the hydrological cycle in basin includes various components like snow melt, which contributes to spring discharge, surface runoff, which can carry contaminants, unsaturated flow in the soil zone, and groundwater flow in the saturated zone or aquifers. These processes are all interconnected through the river network, interacting with things like vegetation, infiltration, and human activity such as well obstructions. Methodological approach. Now looking deeper into the methodological approach, we see two primary branches of hydrology. Number one, physical hydrology focuses on understanding and observing water process. It involves observation, measurements, and deriving the natural laws. And number two is engineering hydrology. On the other hand, emphasize modeling and conceptualizing to reproduce and predict the system's behavior. Together, this help in managing water resources effectively, especially for conservation, restoration, and planning. On the right side, we see the watershed as a hydrologic system based on a system analysis approach. It is treated as a transformation system with inputs like precipitation processes inside the watershed, infiltration, storage, flow, and outputs such as stream flow. This simplified model helps us break down complex natural systems into understandable and manageable components. Physical hydrology, process understanding and monitoring. The first part of our methodological approach lies in physical hydrology, which is fundamentally about understanding, measuring, and monitoring hydrological process. We start by characterizing the catchment. What is a catchment? How do catchment characteristics like topography, land use, and drainage density influence the hydrograph? So, once the catchment is understood, we delve into the key hydrological process: precipitation, measurement and types, aerial rainfall, storm rainfall. Snow hydrology includes snow measurement, snow melt, and modeling. Evaporation and evapotranspiration, measured or estimated AET versus PET. And interception, infiltration, and soil moisture govern how water enters and moves through the soil. Runoff processes, surface flow, subsurface and groundwater flow, total runoff. So the erosion and sediment transport problems, influencing factors, and sediment transport emission. All these elements are quantified through field measurements and scientific analysis, which serve as the foundation for hydrological modeling. Engineering hydrology, modeling and conceptualization. The second half of our approach is engineering hydrology, where the focus shifts to modeling and conceptualizing the process we've measured. Case steps include frequency analysis, using rainfall and runoff data to derive intensity duration, frequency, IDF or DDF curves, and hydrograph generation, creating synthetic hydrographs using methods like the SCS, triangular, Chicago or Huff method, and RR, transformation, rainfall, runoff, routing. This is choosing the type of model, lump, distribute, or semi-distributed, defining the structure, time or space, skills, basin response functions, estimating model parameters using statistical methods, method of moments, less squares. This modeling allow us to simulate water movement, making it possible to assess water availability and flood risk under various scenarios. Integration from measurement to prediction. The beauty of the methodology lies in the integration. Measurements from physical hydrology inform models in engineering hydrology. These models in turn are used in flood frequency analysis, either deterministically PMF or probabilistically through direct or indirect methods. The end goal is to support flood management, infrastructure design, and climate resilience. To summarize, the methodological approach in hydrology involves both understanding natural water process and modeling them to make predictions. This combined perspective allows scientists and engineers to manage water more effectively across different environments, especially in river basins, which serve as our key unit of analysis.